Videos up to now have been talking about solving equalities. This is a look at solving inequalities and using interval notation. So what we're going to do is compare what you're used to, the inequality notation, which is in this first column, showing it on a number line what it looks like. I'm going to introduce you to interval notation, and then this is set notation, so that we have 4 different columns representing 4 different ways of saying the same thing. So let's start with something simple. X is greater than 2. On the number line, we would need our reference point of 0. The key number is 2. Now, in the past, you may have shown it with an open circle, but instead, we're going to use parentheses and brackets. Parentheses correspond to, an open circle. That should not be closed. An open circle. And brackets correspond to a closed circle. Ignore this. Sorry about that. So since this does not have or equal to, and the arrow is pointing to the right, I'm going to put a parentheses here, an open parentheses, to show it goes right up to 2, and then it goes this direction. Now the reason I want you to learn to do that on the number line is because then this looks just like the interval notation. So the way that we show it is an open parentheses with a 2, and it goes all the way to infinity, and at infinity you always show it with a parentheses. If you showed it with a bracket, that would mean it included the end point, and infinity doesn't have an end point. So note something. If I wrote this underneath, it would be 2, infinity. It looks like what's on the number line. So these two are related, and then your set notation and your inequality notation are related, because in set notation we use that squiggly bracket, and then it's the set of all x such that, that's what that line means, x is greater than 2, close the bracket. You'll get the hang of it. Now what if it was x is greater than or equal to 2? We still have 0 as our reference point. 2 is still our key number, but now we would need the closed circle, so the bracket. So the bracket, and then it goes this direction. Remember, my interval notation looks just like this. Includes 2, goes to infinity, but it's closed with a parenthesis. So you can have a bracket and a parenthesis together. I know that's weird looking, but you can. When I get to set notation, I go back to this, and it's just the set of all x such that, and then you just recopy this. So what you're seeing is the set of all x such that, and then again copying what you have in the inequality notation. X is less than 2. Again, we have 0 as our reference point. 2 is our key number. This time it is a parentheses, and since it's pointing left, my parentheses has to be the one that's pointing to the left. So it's the right side of the parentheses because its ends are pointing left. And it goes that way. Now this one is a little bit harder because look, we always want to show our interval notation going left to right. So on the left hand side, where does this end? It ends at negative infinity. It goes to 2. Neither end are included. And then my set notation is just like this with this in front of it. All right, if it's less than or equal to 2, 0, my key number, bracket, going this way, so it would be negative infinity to 2, including 2. And then my set notation, again, matches this one. What if its x is in between 2 and 5? Then my 2 key numbers are 2 and 5. You don't have to show all the little tick marks in between. It's not or equal to, so we're going to have parentheses, parentheses, it's everything in between. So this is going to look just like my interval notation, 2 to 5, that is an interval. I know it looks like it's a coordinate point, but it's not. It's the interval of 2 to 5, not including 2 and not including 5. Here, again, you see the resemblance, it's just this beginning part and then this on the end. This is the same as this. If it was or equal to, we would still have 2, we would still have 5, but this time we have brackets to show that it is included, and in here we would have brackets to show it is included. So these two are very closely the same, and here your set notation is like your inequality. What if one was open and one was closed? Not a problem. One is open, one is closed. It's still everything in between. One is open, one is closed, meaning the 5 is included, but the 2 is not because of the or equal sign. Or you can have just the opposite. Whoops, I meant to make that a line. So this is 2, this is 5. It's going to be included on this end, not included on that end. So my interval notation looks the same. The 2 is included, the 5 is not. You need to get real used to this interval notation because it's going to be used a lot for the rest of this course. So let's just go straight from an inequality to the interval notation. Now, if you need to do the intermediary step of putting it on a graph, you can. But here we have x between 1 and 3, so it's going to be 1, 3. They're both included, so that's all you do. Here we have x between -4 and 0. Neither are included, so it looks like this. This one you have to really think about. X is greater than 5. So the smallest thing is the 5. It's not included, but it's greater than 5. It goes all the way up to infinity. So this one's a little bit harder because here you see both of the numbers. Here you don't see the second symbol. X is less than or equal to 1. So thinking about a number line, which might be helpful in this case, here is our 0, here is our 1, and look at where it's going. It's going to -infinity to 1, and the 1 is included. So do what I just did. If you need to first put it on the number line and then transfer that to interval notation, that's not a problem. All right, let's go the other direction. Take the interval and we're going to write it as an inequality. So here we have from 1 to 4, the 1's included, the 4 isn't. So here I'm going to have an x, looks like that, looks like that. X is less than 4 but greater than 1. You have to read it in two directions. I think it's a little bit harder to go in this direction than it is in this direction. Here we have 2 to infinity. So what does that mean? It means x is greater than 2, not or equal to. Here it's bound by 2 and 3. X is in the middle, 2 is here, 3 is here. It is inclusive, so we have or equal to. Here it goes to -infinity, so again you might want to put that on the number line. So you've got a -3, it is included, and it goes down to -infinity, so it's going to be -infinity to -3, and that is included. That's what we had. So to write it as an inequality, it's that x is less than or equal to -3. So you see the relationship between these two, and then you have to think about what it means, oops, I'm off, to get your inequality. All right, so let's look at solving inequalities. Just like linear equations, you want to remove the grouping symbols by distributing. That's the distributive property. You want to collect like terms, isolate the variable, and divide as your last step. But unlike linear equations, you must reverse the direction of the inequality symbol under two circumstances. One, if the variable ends up on the right, you have to turn the whole thing around because it means x is greater than 3. So in this case, if the variable's on the right, you flip the whole thing. The other time is if you multiply or divide by a negative number in your last step. So let's say you had -3x is less than 6. I divide by that negative. That causes just the symbol to flip. So on this one, you just flip the symbol. On the other one, you flip the whole thing. All right, continuing to the next page, in example 3, we have solved the inequality. And then we're going to show the solution in set notation, interval notation, and as a graph. We've already been given this as an inequality, and that's what we will get as our answer first. So let me rewrite this. So I have 4x plus 7 is greater than or equal to 2x minus 3. We want to get our inequality, our variables on the same side. So we're going to subtract a 2x from both sides. I get 2x plus 7 is greater than or equal to negative 3. Now I've got the variables on the left, so the numbers go to the right. 2x is greater than or equal to negative 10. 2x is greater than or equal to negative 10. I'm going to divide, but I am not dividing by a negative, so I do not flip the sign, and I get x is greater than or equal to negative 5. That is the inequality. Let's do the one that goes with it. The set notation is what goes with it. So I'm going to write underneath it the set of all x such that, now I just rewrite this, x is greater than or equal to negative 5. So now I've got two of the formats. Now I'm going to put this on a number line. I'll use 0 as my reference point. This is my negative 5. It's greater than or equal to, so it includes, and it goes this direction. And now from here, I can go right underneath and write it as an interval. So what I have is, here I've got it as a graph. Here I have it as an interval. Here I have it in set notation, and here I have it as an inequality. So I've got it in all four formats. Remembering that these two are related and these two are related. It makes it a little bit easier. So let's look at this one. Here our x is in the middle. So I want to keep it in the middle. I have two inequality symbols as opposed to the one that I had here. So I need to get everything away from it by adding a 2. That gives me negative 3 is less than 3x is less than 3. And now all I have to do is divide everything by 3, and I get negative 1 is less than x is less than 1. So there it is as an inequality. What goes with the inequality? The set notation. So we're going to say the set of all x such that negative 1 is less than x is less than 1. So those two are obviously together. Now I'm going to put it on the number line. I need a negative 1 and a positive 1. Neither one are included, so it's parentheses, and it goes in between, everything in between, and now from here I can go right underneath it and write the interval notation, and you have all four formats. All right, let's look at this last one. This last one is a little bit tricky. The x is in the middle. It's a compound inequality, but I have a fraction. So we always get rid of a fraction first by multiplying each term by the LCD. So that gives me negative 2 is less than or equal to, those cross cancel, 3 minus 5x is less than or equal to 18. Now I still want to keep the x in the center, so I'm going to subtract a 3 from all sides. Negative 5 is less than or equal to negative 5x, don't drop that, less than or equal to 15. I'm now going to divide by a negative. Remember what dividing by a negative does. This makes a positive 1, flips the sign, positive x, flips the sign, negative 3, because this is a 5. Now we have a problem, because you always want your x to be in between and then those symbols, not greater thans. So what I have to do is turn this whole thing around. It doesn't make sense like this. So you want it to go from smallest to largest. So negative 3 is less than or equal to x is less than or equal to 1. This one had an extra step. As a set, the set of all x such that negative 3 is less than or equal to x is less than or equal to 1, same as this. Number line. My key numbers are negative 3 and 1. They are both included. It's everything in between. And now my interval is negative 3 to 1. It matches my number line. But this part about when you divided by a negative and it flipped the signs caused you to have to turn the entire thing around. So this is kind of an important one.